So welcome all of you. Here today we are talking something about Bresenham's line drawing algorithm. Earlier videos, in the earlier video actually, we have talked about DDA algorithm, which was a line drawing algorithm where we actually try to calculate the pixel positions using the equation of a line, which was y is equal to mx plus b. Okay, using this equation we tried to find out the values of m and b, and then we tried to increment the x value and try to find the value of y. But using this method, what happened, the results which were coming are totally floating points, right? So the results were floating point. So in a way we were doing floating point operations. These floating point operations are costly. So is there a way, because even after we are getting this floating point values, suppose we kept for this screen, this was the value of x, and we are trying to find which y. Okay, so somehow we got a point something value which was 2 point something like this. Okay, but still we have to take either 2 or 3, right? The position which pixel is to be chosen, it should be in terms of x and y, which is integer. So whatever value we are getting, we are anyway going to round it off. So is there a way to make everything integer? Okay, integer processing. Suppose this is your frame. So in this frame, why don't we do one thing? We keep on incrementing x, it is okay, but we should, if at all we are here, then we should be able to judge whether we have to choose this pixel according to the slope of the line, whether we have to choose this pixel or this pixel. Whatever we are choosing, even if the line is in any direction, let it be, we have to choose any one of the pixel around this pixel, right? We cannot choose anything else. So there should be a way where we could find out which pixel we should choose, which can be done in an integer way. Okay, so in a way, definitely, suppose here we have a line starting from this position to, suppose, this position. Okay, it is definitely coming like this. Now here, suppose here line is really nice. Here now you have to decide. Suppose this was the way, you have already selected this position, this is a pixel. Now the next pixel you have to choose. Now for next x, either you will have this pixel or this pixel. Okay, the y value, what should be the y value? Either this one or this one. What do you want to say? Anybody who will see that if we have to choose, then this pixel is the correct choice. Why? Because most of the line portion is in this pixel. So this pixel should be selected, but how? What should be the condition? On what basis this particular pixel can be chosen? So we will see that this was our position already chosen. From here, what is the direction in which this particular line is going? And we will compare the difference from this pixel and from this pixel. How distance, means not distance I should say, but something like how much it is separate from, how much this pixel is separate from this line and this pixel is also separate from this line. We will then find that this pixel is more near to this line, or it is more accurate for this. How we will find this? We have a method. We already understand that suppose this was this is the actual y. Okay, this is your actual y. Let me take another color. This is your actual y. Okay, definitely in some floating point value. If you will take this x, you will get some floating point value which is here. Okay, now this is something, and this is actually your yk. Suppose this is yk, this was actually your y, and this is yk plus 1. Okay, so you will definitely get some value for y. Then you will see whether it is near to yk or it is near to yk plus 1. Okay, is that the way you did in the DDA algorithm? You found the value of y. This value was something, some floating point value, and then you saw it is near to which one, yk plus 1 or yk, and then you have selected one of them. How did you do that? You just rounded it off. If it is more than 0.5, it will go up. If it is less than 0.5, it will come down. Okay, no problem. That is what you did in DDA. Here we don't want to find out the actual value of y. We don't want to go for floating point operation. So how will we do that? We will wait a minute. So let us consider what is the slope. First of all, we will start as we did in DDA. We will think that the slope is positive. Okay, slope is positive. If the slope is positive, what does it mean? The line is going from below to up in positive direction. Okay. Also, wait a minute, let me keep the slope less than 1. Okay. So definitely there are two endpoints starting from here to there. Now we have to determine the pixel position along the line. Okay. Now here we have to keep the track of x positions. This is y. So this is the leftmost portion. Let me call it x naught, y naught. No problem. Then what we will do, we will move on the position of x naught to, it will be x1, whatever, x naught plus 1, what do you call. For this position, now we have to decide which y value should be chosen, isn't it? So basically you can understand that this is the line path, and you have to choose any one of the scan line y. So you have to decide whether this is closest to this or this is closest to it, right? So what you will do here, suppose this line equation is what? Mx plus b, right? Y is equal to mx plus b. Okay. Suppose now this is, suppose xk. Now you want to find yk, what would be the value. So if xk and yk is the something that is to be displayed, or let me take it in a different way, as we did in the last above example. we have considered that x0 y0 is something that has been displayed. Okay, so consider this is xk yk, something which has already been displayed, है ना? Or you consider it x0 y0 only, no problem. Then you have to decide what will be the next position to be displayed. Either it will be x1 and y0 itself, or it will be x1 y1. Okay, x1 has to increase, that is well known. Either y will remain as it is or y has to increase, that is the thing. So let us consider this position at x1, or if it was xk yk, then means in the scan line also, wherever suppose we have already plotted this position, then it is xk yk. Now we have to choose among these two, right? So xk yk we already have. Okay, then let us leave this point. Let us consider this as xk, okay, and this as yk. No problem. This is xk yk. Now we have to decide for what will happen for xk plus 1. Okay. Now considering these things, suppose you have this position. Now basically you have to understand how will you see the difference. Now the y coordinates, here you can see, you will have to calculate, right? Okay, in this image suppose there is some value of y, है ना? Basically this is the portion of yk and this is the portion of yk plus 1. Now there is something that is y actually, as we have taken in the last case. Let me take it again. There is somewhere which is y. Now this y, we will have to find out how much it is distant from yk and how much it is distant from yk plus 1. Okay, yk plus 1 and yk. You already knew this is yk and this is yk plus 1, right? So now you have to decide what is the difference from the actual position y to this position and to the old position yk itself. These two positions, let us give some name. Okay, these two differences, let us give some name. So suppose this is d1, difference 1, and this is difference 2, d2. Okay, so d1, what is d1? d1 is a difference from the last one, from k. Okay, so suppose your y is what? Here your y, this one, what this y will be? At position k it was y is equal to mx plus b, right? X was xk. At xk plus 1, what it will be? Y is equal to mxk plus 1. Just 1 has been increased in x value, plus b. This was what? This is y. So this is now new y, right? This is yk, I should say, right? So now if you try to find this d is what? y minus yk. So you can write it as y minus yk. You will get what are you getting here? Y is mxk plus 1 mxk plus 1 plus b minus yk itself. Okay, let me keep this yk as it is because later on we will use it. What will be d2? d2 is, we know that d2 is above y, so let us for taking it positive, we will differentiate from yk plus 1. From yk plus 1 we will difference yk plus 1 minus y. Okay, so what is it? Yk plus 1, what it will be? I believe yk plus 1 is nothing but yk plus 1 minus y. Is it? Just 1 is increasing in y. Now here you have to understand that what was y? Y is mxk plus 1 plus b, right? So let me keep it as it is here, yk plus 1 minus, what is the value of y? It is mxk plus 1 plus b, right? So you can write it as yk plus 1 minus m into xk plus 1 minus b, right? No problem. So let me keep it like this only for now. This is our d2 and this was our d1, right? Now we have d1 and d2. Now according to the algorithm, let us find, okay, something, we call it the difference among the differences. You have the d1 and d2. Let me find d1 minus d2. What I am doing actually, this was my d1 and this was my d2. So I am differentiating this thing. I am subtracting, I should say, differentiating is not a good word. I am subtracting d2 from d1. Now what do you think? I am subtracting d2 from d1 and I am getting something positive, which means d1 was bigger. Okay, so if d1 was bigger, then it means that y is nearer to yk plus 1, isn't it? In that case, k plus 1 should be, yk plus 1 should be chosen. If at all we perform d1 minus d2 and the result is in negative, if the result is in negative, what does it mean? It means that this d1 is smaller and d2 was bigger, right? So if d1 was smaller, it means that y is nearer to the k value. Okay, so we will plot the yk, we will choose yk with the xk plus 1. So in this way, let me find out the exact value for d1 minus d2. We have d1 as this value and d2 as this value. Let me write it here. d1 is mxk plus 1 plus b minus yk minus this thing d2. What is it? Yk plus 1 minus mxk plus 1 minus b, right? Okay, this minus goes inside. What will happen? Let me keep it first. This is mxk plus 1 plus b minus yk. Now this minus goes inside. It is minus yk, is it? Then minus 1. This minus becomes plus m into xk plus 1. Then this minus is plus b. Okay, let me write it nicely. It will be mxk plus 1, mxk plus 1. This is 2 mxk plus 1. Then we have yk minus 2yk. Okay, 2b also plus 2b minus 1. This is what we are getting. So here using this equation, this is d1 minus d2. Okay, d1 minus d2. This is what we have got here. Concentrate here. In this portion now, we have to understand that this will be considered as our decision parameter. Okay. Now here you can see they are only integer calculations. Okay, but here it is m value. We will have to replace this m value with something. With what? We understand what is m. M is delta y upon delta x. Is it? Yes. Now what is delta y and delta x? Delta y and delta x are vertical and horizontal separations. This is vertical and this is horizontal separations. So this was your line. So x naught, y naught, x n, y n. So this m is what? This thing, yn minus y naught upon xn minus x naught. So if we are thinking about delta y is what? Yn minus y naught. Delta x is what? Xn upon xn minus x naught. So suppose we are trying to replace m by this thing. So what will happen? So what will happen is this thing. We have this d1 minus d2 here, right? Then I am replacing this m by something. 2 into m is what? Delta y upon delta x. Control Z. Delta y upon delta x into xk plus 1 plus 2yk plus 2b minus 1. Here okay, there is something, but we are not getting it how we will do it, right? Then there is something we call a decision parameter given by the Bresenhams. Bresenham has already figured it out. These kind of problems may occur. He had decided something. Let us not go for this. let us choose the Bresenham's idea. Let us choose a decision parameter which is definitely based on this thing only, but in a different way. Decision parameter for the position k, parameter pk, will be delta x into d1 minus d2. This will be your decision parameter. What is d1 minus d2? Now here you have delta x, right? So you can understand delta x is being multiplied here. So m is delta y upon delta x. So delta x will be cancelled out. You will get 2 delta y, right? So 2 delta y into this thing xk plus 1, right? So 2 delta y into xk, and if you will actually multiply, you will get another 2 delta x, but somehow you will understand that later on it will be cancelled out. Let it be. So this is what you are getting here, 2 delta y into delta xk minus 2, here delta x will come, delta x into yk, right? Now here you have 2b minus 1. So let me, whatever here you are having along with the delta x, you will have whatever. Let us consider all those things as c, a constant value. Okay. So now all this thing is in c. If you really want to see what the c will be, it will be what it will be. It will be something like 2 delta y and then plus delta x into 2b minus 1, right? 2b minus 1. Okay, this will be your c. But the thing is, it is independent of decision. Okay, this is something which will lead to the decision, delta y into xk, and this is yk. Okay, these are the two things which will work for it. 2 delta y into delta x minus 2 delta y 2 delta x yk. Okay, so now how it will lead to a decision? You already understand that delta x is greater than 0, right? Delta x is greater than 0. So what is happening now? This yk, either yk is already known, no problem. Okay, what you have to understand is the sign of pk, whether this difference is positive or negative. That thing we are trying to find here. We have just replaced m. Now we don't have m here, right? We don't have any floating point operation. Now we have got this value, using which we can easily find whether the value is negative or positive, and depending on that positive or negative we can decide. So here we have to understand what is the sign of your pk. Okay, so if this pixel suppose yk is closer to the line path, what will happen? d1 is, we have already seen that what was happening, that this was suppose this difference is d1 and this difference is d2. Then if this distance is smaller, then we will get negative value. If d1 is larger, then we will get positive value. Okay, so keeping this thing in mind, we have to understand that if yk is closer to y, it means that d1 was less than d2, and since this was the case, the decision parameter pk will lead to negative value. Okay, in this case what you have to do, we will choose what we are choosing, the yk, the lower pixel. Choose lower pixel. At the same time, if we are getting a positive sign, which means the difference was this difference. Positive means we are subtracting d1 minus d2, so d1 was larger. d1 was larger means it is distant from the actual y, and yk plus 1 is nearer. Yk plus 1 is nearer, then in that case you have to increase the y and you have to choose the upper pixel. In this way, what will happen? You have just to calculate the yk, and depending on this thing, you will be able to find the value of the next value for your y. So this was your y. In this way you were trying to find out. Now if you consider what will be your next p value, this was pk. If you try to find pk plus 1, then similarly you will use the same equation here. What is this? 2 delta y into xk plus 1 and minus 2 delta x into yk is yk plus 1. Okay, plus c you can keep it, no problem. Is it? So one more thing that I can find here, let me tell you. This is pk, this is pk plus 1. For you, let me do one thing. This is pk and this is pk plus 1. Let me try to find a difference of pk plus 1 and pk. What do you think? What will happen? Pk plus 1 minus pk. So here actually you can say you are having these values, okay, minus this thing. So let me write it here. 2 delta y into xk plus 1 minus 2 delta y into xk. Let me take 2 delta y common. It will be xk plus 1 minus xk. No problem. Again minus 2 delta x into yk plus 1 minus yk plus c minus c, right? It will be cancelled out, no problem. So this is what is leading to our decision. This is something, right? Okay, now this is pk minus pk plus 1 minus pk. If I want to take this pk on this side, what will happen? Pk plus 1 is equal to pk plus this particular thing, 2 delta y into 2 delta y into xk plus, okay, here what do you want to see? We know that what is the difference from xk plus y and xk. It is just an increase of 1 unit. So xk plus 1 minus xk will be just 1, right? Minus 2 delta x into yk minus yk plus 1 minus yk. We cannot judge what it will be, so we are keeping it as it is, yk plus 1 minus yk. So this is something. Now you have got this pk plus 2 delta y minus 2 delta x into yk plus 1 minus yk. Okay. Now here yk plus 1 minus yk, it will be either 0 or 1, right? It will be 0 when the yk plus 1 is yk itself. It will be 1 if this yk plus 1 is the next unit of yk. Okay. So this is the case. It will, you understand that it will also depend on the sign of pk. Okay. If at all it was negative, in that case it was 0. If it was positive, it was 1. So now you will have to do this by increasing the value of x by 1. You will have to repeat this every time. Okay. So you understand that every time the x is increasing, only the y value you have to decide which will be, right? Okay. So for each x position, you will start from the left coordinate. The first position is already given, and if you think about the parameter p value p0, so the first parameter p0, what it will be? p0 will be 2 delta y. This is nothing, 2 delta y minus, it will be actually delta x. If you will try to find out using the value of m, delta y upon delta x, this is what you will get. So consider p naught is this. You already know what will be the formula for pk. Okay. So you already know the value of xk, yk, and so then in each iteration you will keep on finding this value. So what we do is, whenever it is given, at first we will try to find out the constant values like delta y, delta x. Okay, and then we will start finding the value of p naught, and after that in every iteration we will try to find out the new value of pk. Okay, so this is how Bresenham's algorithm is done. I believe I should give an example as well. So let us consider an example. Let us take the example from the book of Hearn and Baker, where let us suppose there are two endpoints starting from 2010 to 3018. Okay, this line actually we have to find the in between points. Okay, so first of all, what we are going to do, let me change the color. First of all, we will find the delta x. What is delta x? 30 minus 20, which is 30 minus 20, which is 10. Delta y, what is delta y? 18 minus 10, it is 8. Initial value of p naught. P naught is what? 2 delta y, 2 into 8 minus delta x minus 10. Okay, 16 minus 10, it is 6. Okay, you have these values. Now while calculating the increments, you will have to find this thing also, 2 delta y minus 2 delta x, these kind of things, right? So what is 2 delta y? Let me keep it initially 2 delta y. 2 delta y is 8 into 2, 16. 2 delta Okay, 2 delta x actually we don't need, we need sometimes 2 delta y minus 2 delta x. What is it? 2 delta y is 16 minus 2 delta y is 16, delta x is 10, so it will be 20. 16 minus 20, it is minus 4. Okay, now you have these things. Now it is better to prepare a table. Okay, so in this table you have the iteration number, then your pk, initially it was 0, so p0 was 6. The initial since this thing 20, 10, so depending on the value of p0, whether it was positive or negative, it was actually positive. So since it was positive, so y value will increase, right? So let us assume what will be your x k plus 1 and y k plus 1. This is x will definitely increase from 20 to 21, and this is 11. Done. K is 1. What will be pk? You will have to calculate. P1, it will be, formula if you remember, it is pk, which was p0 plus 2 delta y minus 2 delta x into yk plus 1 minus yk. Okay, so what was p0? P0 was 6 plus 2 delta y was 16 minus 2 delta x. Okay, okay, we have to see whether this thing is positive or negative. Yk plus 1 was 11 and this was 10, so it is 1. So 2 delta x is 10. Although if it is something like this, we already know, we have calculated this minus 4 here. So 6 minus 4, which is 2. Still this is positive. Let me keep it 2. It is positive, so it will increase 22 and 12. Now let us take 2. Here we have to calculate pk. So it has increased by 1, so we will consider this thing, 2 delta y minus 2 delta x. So last p was 2. Let me keep it here only. 2 plus minus 4, which is minus 2, right? Minus 2. So since it is negative, now here it will not increase. It will be 23, but it will remain 12 only. Okay, again it is minus 2. Now what we are going to do, since it has not increased, we will keep we will take this value only, because it becomes 0. So only 2 delta y, so it is 16. Minus 2 plus 16, which is 14. Okay, since it is 14, we will keep it as 14, and here it is 23, 24, and it will increase. It will be 13. Similarly, here it will be 14 and then minus 4, right? So it is 10. Still it is positive. So 4, it is 10. It will be 25, and it will be increasing 14. Now so here for fifth iteration it is still 10. Okay, so 10, again it has increased, so minus 4, it is 10 minus 4 is 6, so it is 6. It is still positive, 26 and 15. So 6, again it is minus 4, which is 2, so it is 2, and it will be 27, and it will increase, it will be 16. Okay, now it will be 2 and minus 4, it will be minus 2. So in 7th iteration it is minus 2, so it is 20, it will definitely increase, it will be 17. No, it will actually, it is negative, so it will not increase. Then it is minus 2. Now it has not increased, so it is plus 16, which is again giving you 14. So here you are having 14. In 8th iteration it will definitely increase, however it will also increase. Then you have 14 here, minus 4 again, it will give you 10. So in 9th iteration you are getting 30 and 18. This was your target. So starting from that particular 2010 you have reached 3018, and these are the intermediate pixels, and you have done only the integer calculation. So this integer calculation makes it faster. So this was the case when the slope was positive and the slope was also less than 1. Since the slope was less than 1, we were understanding that what was happening, this line is like this, x is continuously increasing, and we have to find the value of y. Okay, now if you think what to be done, suppose this thing, whatever we have learnt here, it can be easily generalized to all the arbitrary slopes and ways. If the slope was positive and it is greater than 1, what we have to do? We have just to interchange the roles of x and y. We will keep, if it is like this, slope is like this, then we will not increase x, we will increase y by 1 unit, and we will find the value of x. That is the thing. So similarly, these are the few things that you have to do in the Bresenham's line drawing algorithm. Okay. So for now we have completed Bresenham's line drawing algorithm. Next thing will be your I believe circle drawing algorithm. We will see that circle drawing algorithm also. For now I will tell you that go through the book also, the Hearn and Baker, only a few pages are there, you will easily understand it. Okay, thank you.